Unit 10.3 is trapezoids. The formula for the area of a trapezoid is 1/2 the height times the sum of the bases. 1/2 height times sum of bases. Now, some formulas charts will put 1/2 sum of bases times height, which is fine because multiplication is commutative. And they probably do that because, remember, 1/2 the sum of the bases is the median. So substituting median in place of half sum of bases, we would get area is medium times height. So 1/2 height times sum of bases, 1/2 sum of bases times height. Half sum of bases is median, so median times height. You may also see it like this. Height times base 1 plus base 2 with the 2 on the bottom over 2. I'm going to use what's in red, 1/2 height sum of bases. Okay? Now I'm going to do the whiteout thing so we can concentrate on the work. Okay. The formula for area of a trapezoid is 1/2 the height times the sum of the bases, so we would write our formula down. We would need some terminology. Remember that a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. The opposite sides that are parallel are called the bases. We normally call the upper base base 1 and the lower base base 2. The height of anything is how tall it is from top to bottom, so the height of that trapezoid is 5. So we're going to have area is equal to 1/2 times the height, which is 5 inches, times the sum of the bases, upper base 7 inches, lower base 13 inches. We're going to go ahead and do what's in the parentheses, find the sum of the bases. So we get 1/2 times the height, 5 inches, times the sum of the bases, 20 inches. When you add, the name stays the same, inches. When you add, the name stays the same, inches. Now we're going to multiply. Half of 20 is 10, times 5 is 50. We multiply the numbers, and you multiply the names, and you get a new name. And when you multiply with like bases, you add the exponents. Area, 50 square inches. Any questions on number 1? Okay. Number 2. Number 2, we want to find the area. Area is 1/2 height times sum of bases. And so we get area equal 1/2 times the height, which we don't know, times the sum of the bases. Upper base is 12. Lower base is 21. And we need to find the height. The height's not even drawn. We're going to draw it over here on the side where there's some stuff. When we draw it, we get a right triangle with some stuff on it. So we're going to extract that right triangle. We've got 50 degrees. We've got 10, and we want to find the height. We're going to have to use a trigonometric ratio. So we're going to write down the angle 50 degrees. The height is the leg opposite the 50. The 10 is the hypotenuse. Leg opposite hypotenuse is sine. So we have sine 50 equal. Sine says you put leg opposite on top. Hypotenuse 10 on bottom. We can cross multiply. 10 times sine 50 is equal to h. So the height is 10 sine 50. Let's go ahead and solve and round and plug in. You could not solve and round and plug in and keep it exact. We'll go ahead and do that. 10 sine 50 7.66. So we're going to plug in for height 7.66. So we get area equal 1/2 times height 7.66 times sum of bases 33. So we just go to the graphing calculator here, 0.5 times 7.66 times 33, 0.5 times 7.66 times 33, 126.39. $126.39. I think I'm gonna double check. Yes. Okay. Okay, let's do a little widening out and move to number 3. Form a fair of a trapezoid. 1/2 height times sum of bases. And so we get area equal 1/2 times the height times the sum of the bases. Upper base is 8, lower base is 12. We don't know the height. So we're going to draw the height. It makes a right triangle, but all we know is one side. So that's no good. But there's something special about this trapezoid. It's an isosceles trapezoid. It's isosceles because it has equal legs. Now, there's some special properties of an isosceles trapezoid. So what we're going to do is go ahead and draw both altitudes. When we do, in the middle we have a rectangle. So if the top is 8, then the bottom is 8. The whole thing is 12. 12 minus 8 is 4. In an isosceles trapezoid, if you draw the altitudes to the base, the two triangles are going to be congruent. Now, that only happens in an isosceles trapezoid. If those are congruent, then those little bottom pieces are the same. So what's left when you do 12 minus 8 and get 4 can be divided by 2 to get each one of those little pieces. Now, that gives me enough to find my height because I now have two sides of a right triangle, and I can use c squared equal a squared plus b squared to find the height. C squared equal, forget that 8 was even there. This is getting weird. Just a second. C squared equal a squared plus b squared. The c is the 8, so we're going to have 8 squared equal a, which is 2 squared, plus b, which is the height square. We can do the exponents to simplify, so we would have 8 squared, which is 64. Let me white out all that stuff that's popping up. I wrote over whiteout, and now when I erase, what I wrote on the whiteout comes out. From under the second whiteout, it's kind of weird. But anyway, uh, that's my fault. So 8 squared is 64 is equal to 2 squared is 4 plus height squared. We're now going to undo addition by subtraction. We get height square equals 60. We get rid of the square with the square root, and we get height equals square root 60. Now that's square root 4 times square root 15. Square root 4 is 2, so you get 2 square root 15. That's the short version. Sorry about the stuff jumping around here. I make a mistake in erasing the whiteout under the whiteout keeps coming back on me. So I apologize for the continual cleanup, but we'll get there. So again, 60 is 4 times 15. Square root 4 is 2, so we would have 2 square root 15. That's the shortcut method, so the height is 2 square root 15. Now, if you didn't understand the shortcut or it wasn't going to happen in your mind, then you would have to do the prime factorization method. We would rewrite it as the product of its primes. Circle pairs for square root. Make a new radical. From the set, 1 pops out. What didn't get circled goes back in. And then you multiply, and you get 2 square root 15. Either way, for height, we have 2 square root 15. So we're going to do what's in the parenthesis. We get 1/2 times 2 square root 15 times the sum of 8 and 12, which is 20. Now we're going to do multiplication. We multiply the numbers. Half of 2 is 1 times 20 is 20. And the name tags along square root 15. Any questions on number 3? We knew that in an isosceles trapezoid, we know that the legs are equal, base angles are equal. If you draw the altitude, you get a rectangle and 2 congruent triangles, and we could use that information to help us find the missing height. Okay? All right, that brings us to daily work 10-3. Notice the fine print says round to the nearest tenth. We'll go ahead and start with number 2. It said round of the nearest tenth up there. So we're going to find the area. The formula for area of a trapezoid is 1/2 times the height times the sum of the bases. We're going to plug in what we know. 1/2 times the height we don't know. But the bases we do know, 20 and 30. We're going to have to find the height. So we could draw it on either side. Over here, it's not going to do us much good because there's nothing over there. But on this side, if we drew it, we'd have a right triangle with some stuff in it. So we're going to extract that right triangle. We're looking for the height. This angle's 62. This is 13 feet. We're going to have to use a trigonometric ratio. And so we're going to put the angle 62 degrees equal. The sides are the leg opposite. 13's the hypotenuse. Leg opposite, hypotenuse is sine. Sine says you put leg opposite over hypotenuse. And then you solve. We could either cross multiply or say we're going to get rid of division by multiplication. So the height is equal to 13 sine 62. So we're going to do 13 sine 62. And we get 11.4783. We'll just make it 11.5. And then we continue solving. So area equal 1/2 times height 11.5 times sum of bases 50. So now we're going to multiply half of 50 is 25 times 11.5. 25 times 11.5. 287.5. So the area is 287.5. Okay. Let's just look at number 6. It looks like it's a little bit complicating. Let me get rid of some of this other. We have an isosceles trapezoid. We know that because it's got equal legs. The formula for area is 1/2 height times sum of bases. So we're going to have area is equal to 1/2 times the height, which we don't know, times the sum of the bases. The upper base is 6, plus the lower base we don't know. So now we have to find two things, height and lower base. This is an isosceles trapezoid, so we draw both altitudes. What we get is a rectangle and two congruent triangles. When you draw both altitudes in an isosceles trapezoid, you get a rectangle in the middle with a pair of uh, congruent triangles on the edges. Now, we need to find the height. We also need to find the base. This little piece of the base is 6. We're going to need to find the other two little pieces of the base. We know they're congruent. And add those all up to get the lower base. So I'm going to extract a triangle. This is 8. 50 degrees. Try again. I need to find the height, and I need to find this little piece. I'm just going to call it A. We can't use the Pythagorean theorem. We're going to have to use a trigonometric ratio. So we're going to put the angle 50 degrees is equal to, it doesn't matter which one you find first, we'll just go ahead and find A. A is the leg adjacent to 50. 8 is the hypotenuse. Leg adjacent hypotenuse is cosine. Cosine says you put leg adjacent A over hypotenuse 8. We could undo division by 8 by multiplying by 8, or you could cross multiply. Either way, you get A equal 8 cosine 50. So 8 cosine 50. And we get 5.1 rounded. So A is equal to 5.1. We'll go ahead and do a trig ratio to find H. We're going to put our 50 degrees again. H is the leg opposite the 50. Leg opposite hypotenuse is sine. Sine says put leg opposite H over hypotenuse 8. Undo division by multiplication or cross multiply. And you get H is equal to 8 sine 50. So we do 8 sine 50. We get 6.1 rounded. So the height is 6.1. This little piece of the base is 5.1. Therefore, this is 5.1. Two 5.1s is 10.2. A 10.2 and a 6 is a 16.2 for the lower base. This plus this plus this. That's a 5.1. It's not going to work for me. Okay. So now we got all we need. So we're going to find the area. We'll just go ahead and punch it all in as we see it. 0.5 times 6.1, 6, 16.2. 6, 16.2. Okay. Enter. 67.71. Or thereabouts. Okay. Double check that. 67.71. Yes. All right. 7, 8, and 9 are some word problems. And then there's another string of them for you to practice on, which is good because you need the practice. Let's take a look at the word problems. Maybe I need to work one of those. Just look at number 8. It looks like a nice one. A trapezoid has a height of 14 inches and has a perimeter of 306. If the legs have a sum of 68, what is the area? Wow. Area, perimeter, area of trapezoid formula is 1/2 times height times sum of bases. So area is equal to 1/2 times height. It has a height of 14 inches. Times the sum of the bases. We don't know that. So we don't know either base. But we know the perimeter, which is the distance around, is 306. It says the legs have a sum of 68. So the two legs add up to 68. If the whole perimeter is 306, we could subtract and get 238. What would that be? Well, it would be these other two sides added together, which is the sum of the bases. So the sum of the bases is 238. We don't know what each one is, but we know that their sum is 238. So we're going to make that whole part 238, and that's inches. So we get area is 1/2 of 14, which is 7 times 238, which was the sum of the bases. One 666. Square inches for the area of the trapezoid. Any questions on that? So got you thinking a little bit on these problems, we hope. That's the objective. And then there's some for you to practice on your own. And that brings us to the end of Unit 10.3.